Hey everyone, it's Mr. Canfield, AB Calculus, Chapter 21, Part 2, the hard problems. All right, so, the not as straightforward problems. So, we talked last time, and anytime we're looking at some function we want to find its absolute max or min on an interval, first thing to do is, oh yeah, I have hands again, whoa. We want to plug in the endpoints and check those y values, but those aren't the only ones that we want to check. We also want to check y values at critical points. So I'm going to find these in a minute. Oh yeah, you can't do synthetic division when it's not a polynomial, so synthetic division is no more. I won't be doing that for any more of the problems today. So let's see. First things first, got to take the derivative. Oh. If we started with x squared over x squared plus 3, that means I got to do quotient rule. So I'll take the derivative of the top, leave the bottom alone, minus the derivative of the bottom, leave the top alone, all over the bottom squared. Okay. So I am trying to find critical numbers. Critical numbers can be when the top is 0 or when the bottom is 0. So it's very, very important that we talk about that second piece because we haven't really talked about that before. So let's just think about this really quick. 0 over some number, and if I did this in a video recently, forgive me, I'm mixing my calculuses together. So 0 over some number, as long as this number is not 0, because 0 over 0 is kind of weird. But 0 over some number is equal to 0. So like a critical number is when the derivative is equal to 0. So why don't I just set the top to 0? And I'm going to show you an advanced factoring technique. So before, like, so you might say, well, let me distribute and combine like terms, and then I'll worry about factoring. Yes, I get you. However, if you look at what we have right now, I've got a 2x here and I've got a 2x here. I actually can pull the 2x out from this. So then we lose the 2x, we lose the 2x, and we're just left with the insides. This, to me, is very advantageous because the x squareds cancel. We're just left with a 3, and we're left with 6x is equal to 0. Wait, x is equal to 0. Okay. So we have -1, we have 1, we also have 0 that we need to check. Additionally, I need to examine, because we have a fraction, sometimes they call this a rational function, if they want to be technical. Let's take some non-zero number over 0. What's that equal? That equals nope. When we were doing limits, this meant usually there was an asymptote, and there's some kind of infinity or something that we might be dealing with. So this is messed up. So I need to ask myself, hey, x squared plus 3 squared, when does that equal 0? I just kind of gave it away by accident. So you could FOIL this out, then factor it. Or you could realize this is already factored, take the square root of both sides, get x squared plus 3 is equal to plus or minus 0. Little joke for you there. There's no such thing as -0, or +0 for that matter. Subtract the 3 from both sides, take the square root again, get plus or minus the square root of 3. Wait. We don't do imagine. We don't do square roots of negative. No, nah. Okay, so we don't have any critical numbers from the denominator. There's no x value that will ever make this equal to 0. So in this course, this is unsolvable. It's actually solvable, but it's not something that we're concerned about. We stick with real numbers in this course. So cool, so those are my 3 values I need to check, and I am feeling super duper expeditious. Oh, it's a heart. in in BC calculus, we learn how to get some silly things like that to show up. Let me just reset my calculator memory. And then let's see, the original function. This is a perfect opportunity for me to throw my phone on the table. Oh no, I'm so sorry. All right. A better teacher would edit that out. So if I'm going to type this into y equals to then pull some y values, I need to be careful. And my recommendation is, if you are not comfortable with how calculators read our inputs, put the whole numerator in parentheses, close it off. Divide by, put the whole denominator in parentheses, close it off. If you don't do this and you don't understand all the ins and outs of what the calculator does, you might make a silly mistake sometimes and actually be putting the wrong function in. If you want the bare minimum for this particular example, you could type x squared divided by parentheses x squared plus 3. You don't even need to close the parentheses. And I can explain why, just a little calculator theory for you if you're interested. Otherwise, skip to, you know what to do. Like, you know how to do the math for this part. So the calculator follows the order of operations to a T. So the first thing that it says is, okay, do I have any parentheses? Ah, yes, I have this parentheses. So it views this until the parentheses stops as one unit for the rest of the problem, essentially. And it takes care of the inside of that first, and then it treats it as some number. So the parentheses opens, and since it never closes, it goes from there to the end of the line. So then we do exponents, and so that's when the x squared happens. So whatever the number for x was, that it gets squared. Then multiplication and division happens. So now we take this number divided by whatever we got here. So it does this in order, but if there had been a plus sign up here or something like that, it would mess things up. Sometimes people will just say x squared divided by x squared plus 3 like that. And so it's gonna do the division first, and then it's gonna add the 3. And so because of that, we need that parentheses. So anyway. Let's go to the table. I need -1, 0, and 1. -1 was 0.25, 0, well, that's a fun one. 0, 0, and no, it wasn't. 0 was 0, and 1 was 0.25. It is, it can be good to write these in order so you don't make a stupid that I made there, but anyway, that's not the part that you're here for. You're here for making sure you know how to do the derivative and find the critical points right. That's my assumption. All right, let's see. So for this one, oh, it's a quotient again. I can do the quotient rule. Oh, I'm so surprised. So I'll take the derivative of the top. Oh wait, f prime is equal to, okay. 2 parentheses x squared plus 1 minus, take the derivative of the bottom, it's 2x, now 2x. All over x squared plus 1 squared. Okay, let's actually talk about the denominator first. So if the derivative is undefined, that's another place where we could have critical numbers. X squared plus 1, since x is squared, and again, if you're not sure, just try solving it and see what happens. But look, this is always positive. Something that's always positive, and then you add 1 to it. Will that ever be 0? No. I don't even need to go through the rest of the solving of that. I do need to solve the numerator, though. So on this one, it doesn't, there's not a 2x I can pull out of both of them, so I am just going to distribute. Yeah, that was a good choice for this one. So now I have some like terms, so I can say -2x squared plus 2. I'm going to add the 2x squared to both sides. Divide by 2. So this actually says x is equal to plus or minus 1. Okay. So the interval they gave me on this one was -3 to 3. So -3, and then I've got -1, and then I've got 1, and then I've got 3. So I can just go in. I mean, yes, you can plug these in by hand. That's generally, oh, I'm getting a phone call. I gotta turn the thing off.